Okay, we're starting 2.4 today. 2.4 and 2.1 go together very well in terms of the content. So that's why we're skipping ahead to this section. Your next quiz will be on these two sections. So today we'll be using the imaginary unit I to write complex numbers, and then we'll be adding, subtracting, multiplying, and simplifying different complex numbers. All right, so the imaginary unit, which you had a little discussion about this in Algebra 2. There are going to be some problems. They have an example here of x squared plus 1 equals 0 that doesn't have real solutions. We'd have to subtract 1, take the square root, and we'd get square root of negative 1. Okay, so there's some complex math problems that just can't stop when they have non-real solutions. They have to keep going. So that's why they came up with these imaginary units, so we can come up with solutions for problems that have non-real solutions. I know that seems kind of weird. Like, where do we use these at? But you got to just trust me. There's sophisticated problems that are multi-step that need solutions to things like this to continue. One, they give an example here in the margin. Complex numbers are often used in electrical engineering. Okay, there's actually an application on exercise 87 that goes over that. So it's a means to the end, okay? All right, so let's go ahead and go to page 5 in your notes and get going on this topic. Okay, so the imaginary unit, to help with that problem I talked about, is defined as this. We call it I, the imaginary unit. It's equal to the square root of negative 1. Okay, write that down. And if I square both sides of this, we can also say I squared is equal to negative 1. There'll be times where we want to substitute that in. Okay. Complex numbers always take on the form A plus BI, where A and B are real numbers. All right, so here's how we're going to deal with this negative under a radical using this imaginary units. Let me add a little step underneath here that will help you realize what's going on. When we have negative b, that just means it has a negative 1 in front of it, right? Like a negative 1 times b. There's a property of radicals that says we can break it apart if we have a product. So I can express this as square root of negative 1 times square root of b and break that apart. Okay, and now we have something to substitute for square root of negative 1 now. It's I. Okay, whenever we see square root of negative 1, replace it with I. So this is equal to that, I square root of b. Okay. All right, so with that in mind, let's take some of these real basic negative square roots. In the past this year, we've said no solution to these, but now we're going to actually simplify these and get an answer. So when we have square root of negative 25, it's square root of negative 1 times square root of 25. Now, once you get used to this, you can skip this step, but maybe at least try it a couple times. Okay, so since this is now going to be replaced with I, and this is now 5, we're going to say this is just 5i. We usually put the coefficient in front of the imaginary unit, so 5i is the solution. Okay, let me show you 3, and then I'll have you try 2 and 4. Here's what I like to do for a problem like 3. This one doesn't have a perfect square root like 1 did, but it does have a square that goes into 8s. So why don't you write this down? We have negative 1, which is the imaginary unit. We have 4 that has a perfect square root. Okay, so these are the parts I can simplify. I can take one more step and kind of break this up as square root of negative 1 times square root of 4 times square root of 2. Or you can just take the parts that we can simplify, circle, and bring them out. Like so. Okay, so this comes out as I, and this comes out as 2. So I have 2i, but this 2 stays in there. So 2i square root of 2 is the answer there. Okay. If you don't quite see it, I guess this is the step I skipped. I can break it apart like I did here. So I'd have square root of negative 1 times square root of 4 times square root of 2, right? What can I simplify right here? This is the 2i. Square root of 2 stays the way it is. Okay, try 2 and 4. Go ahead and pause and give yourself about 1 minute to try. All right, here's number 2. The negative 1 comes out as I, and this comes out as 9. So there's nothing left inside. 9i. This one, though, doesn't have a perfect square root. So try to break it down so you can find the perfect square. So 9 is going to come out as square root of 3. So we're going to say 3i square root of 2. Now let me show you something about this one. When we get to complex numbers, all right, they're usually going to have us write the I last. I'm okay with you guys expressing it like this, but when you check it in the back of the book, they may also write it like this: 3 square root of 2, then I. Okay, just be careful. Sometimes it looks like the I is under the radical. So if you do this, just make sure you're careful with that. You could even put parentheses around this if you want to. 3 square root of 2i like that. All right, so I don't care which one. Just obviously it's a product of 3 things, so you could rearrange it. It still works. Okay, let's take a look at 5. All right, this one has a perfect square. It's really an extension of what we just did. Like here we had a perfect square. This one has a perfect square. It's going to be 7i right here. This one is 2i. We can combine these. These are considered like terms. So we end up with 5i for number 5. Okay. All right, so I'm going to do most of these, but I'm going to have you try some of these as we work through it. So just keep following along. All right, this one also has perfect squares. Then we're asked to multiply them. So here we get 8i, and here we get 3i. You can't multiply those together yet unless they're positive. We're going to get to that here. And I should probably cover it right now, but for now, let's simplify that to get 8i times 3i. And now that gives me 24i squared. Okay, one last step. Whenever you're going to see I squared, you're going to replace that with negative 1. Okay? So 24 times the negative 1. All right, 7 and 8 are very similar. Let me walk you through 7 and then have you try 8. Before you add these together, you got to have like radicals. Like radicals looks something like this, like a 5 square root of 2 plus 3 square root of 2. I can add those together and say I have 8 square root of 2's. Okay, but right now I don't have like radicals. So we're just going to have to simplify these both separately like we were doing up here. Okay. All right, so square root of negative 4 is 2i. Square root of negative 144 is 12i. So now we get 6i plus 60i. And we get 66i. Okay. 8's a little different, but I'm going to just push you in the right direction. Give you a minute to try this one. This one just simplifies, doesn't have perfect square roots. Let's see if you can simplify that one. Go ahead. Okay, sometimes students get confused what to do with these coefficients. Let me kind of break this down as specific as I can. Square root of negative 1 comes out as I, and the square root of 4, which is 2, comes out. But some people are like, what do I do with that 2? Do I add or multiply? Remember, the 3's out here next to it, meaning multiplication. When things are next to each other in algebra, it means to multiply. Or maybe this will help too, right? I have 3 times I, square root of 4 coming out is 2, and then that 2 stays in the radical. So that's really the math I have going on to simplify this. Okay? I mean, you can skip this step if you get it. I understand. But this is instructional, so 6i square root of 2. I showed all the work. Next one, once again, if I break it down piece by piece, this is going to be I, this is going to be 3, and then the square root of 2 stays in there. So I have 12i square root of 2. Okay. Now they're like radicals. I do have an imaginary unit there, but that's okay. But to that step I was talking about before, we can add these together. All right, so 6 minus 12 gives me negative 6i squared root of 2. Or the answer there. That was probably the toughest one so far. Okay, 9 and 10. Now we're going to start adding and subtracting complex numbers together. So when you add and subtract complex numbers together, you can add the a parts together and you can combine the bi parts together. So there's really, these parentheses aren't doing much except for just separating the two complex numbers. So I can jump right to the answer. Okay, I'm going to add these two together here. 2 plus negative 5 gives me negative 3. And 3i and 4i gives me 7i. Okay, you try 10, but just realize we're subtracting now. You're subtracting the 12 and the 6i. So don't forget to apply that. Go ahead. All right, doesn't take long. You might want the step in between is showing that you applied the negative. So it's a negative 12 and minus 6i. There we go. A plus bi form. By the way, that is what they mean by standard form. If it says write each result in standard form, they're talking about a plus bi. Okay. 11 just has 3 complex numbers now. All right, this 8i can be expressed as 0 plus 8i if you want. I do have a minus and I have a plus, so just be careful of that. So 8i, this becomes a negative 6 and a positive 2i. And combine what you can. Negative 6 plus 9, 3. 8 plus 2 is 10, take away 5. Okay, so there's 3 examples of adding, subtracting, and adding and subtracting the same problem. Okay, 12, 13, and 14 involve some multiplication. Here we should distribute the 2i to both of these terms. So we get 6i plus 10i squared. Every time we see I squared, we're going to replace it with negative 1. Okay, and then in standard form means I'm going to put this first now. So negative 10 plus 6i. All right, you're going to do the last two. FOIL 13 and 14. You also need to make sure you FOIL that. Actually, you're not ready for 14 yet because there's a property I have to go over. So just try 13, and then there's something else I need to cover before you try 14. Okay, there's the 4 components of FOIL, F-O-I-L. All right, these can be combined, and then when I replace this gives me a positive 3. So add this positive 3 to that 7, and I get 10. Okay, before we do 14, I want you to turn the page over and I want to show you a property on this other side. We don't need all that room for 17 and 18, so we're not doing 17 and 18 right now, but I'm just trying to show you that I want to show you this property at the bottom. So cover that up and maybe just draw a dividing line like I have here. You just need about that much space. Okay, thanks. I have to do another video. So let me get this situated. There we go. All right, so it reads the square root of a times square root of b equals square root of a times b only when they are positive. Okay, go ahead and pause it and write that down, and I have to start a new video.